Welcome to GIS Programming Fundamentals. This is Dr. Tadeusz speaking. I'm the professor for the course, and we have also two teaching assistants. In this video, we will discuss the objectives, requirements, logistics, and guidelines for the course. The focus of this course is GIS programming through the use of the Python programming language. We'll discuss general programming concepts as well as Python syntax. One element we'll discuss in depth is the ArcGIS Python library called ArcPy. We'll use ArcPy as well as standard Python features to process and analyze data. A key objective for this course is to automate batch processing to enhance workflow efficiency. With Python, you can process large numbers of records, files, databases rapidly. These are some of the basic capabilities we'll target with this course. Let's view some sample final projects for a clearer view of what's possible when these skills are mastered. Our students apply this course material at their workplaces and in their research projects. Here's an example of two students who took this course a few semesters ago. Morelli's final project developed a process to simplify complex postal code polygons using variable grid sizes. Bhutan's final project automated a process for groundwater contamination analysis that had previously been performed painstakingly by hand. Both of these projects process and automatically map data and create HTML outputs to display the results. Near the end of the semester, students submit two videos, part one to describe the problem they tackled and their approach, part two to develop the tool that was created. We'll look at Morelli's part one video and Bhutan's part two video to hear what they have to say about their work.
Hello, my name is Bill Morelli. I'm here to talk about the gridded coastline simplification of postal polygons for my GIS540 final project. I work for a package delivery company. I'm an engineer, and we use postal codes a lot in this business to plan for pickup and delivery territories. And they are used because they're common throughout the world. They allow for unique creations of geographies, and service areas can be assigned based upon these that link back to the addresses. So GIS services are used for complex geospatial operations to manage these service areas. Aggregations are used to create the service areas from the postal polygons. Business data is also joined to these postal polygons and service areas to do analysis of location patterns. They're drawn in web applications to display this information, and there are spatial queries performed like within spatial streets within driver service areas and GPS stops within postal polygon searches. Calling these spatial web services across networks from remote locations, it requires a lot of memory. We all know using even ArcGIS desktop running spatial operations is very memory intensive. So these are, in the web services, JSON is used to pass this information across, which is large formatted text of the geometry. So the postal codes that we purchase, postal code polygons we purchase from vendors, are very detailed, especially along the coastlines. They have high vertex counts, which makes it really difficult to do these operations across the network. So a coastline simplification process is needed to remove the complexities, but also maintain the internal borders, where we need those to be accurate because they are abut up to adjacent territories, must be topologically correct, and must also maintain the shape so they tie back to the streets that contain the addresses. So grids I've created grids to replace these coastlines and reduce the vertex counts. Use uniform grids at first, as you see here up in the top right. This is an example from Puerto Rico. So they were all the same size, I believe 1,000 meters I used here, which Puerto Rico doesn't have much variation in postal code size, so it seemed to work very well. It still maintained some of the shape, but it really reduced the size of the vertex count because grids are very, very efficient when it comes to displaying information. But in large countries, in Canada, like we see here down on the bottom in the western part of Canada, in urban areas, we need grid variations in the sizes, because in the urban areas, we'd like to have smaller grids, but in the large areas, we don't really need to maintain as much shape, and the grids can be larger. So this is what prompted me to create my script tool, which you're seeing here, two of the requirements to have a GUI and to have a button in ArcGIS. I wanted to start out with the GUI because this is really where it maximizes the benefits of having this tool, because the user is able to control the size of the polygons that they're looking for. A small and a large area is able to be put in to select from the postal polygons, and you can create small, medium, and large grids based upon this, and that's also controllable by the user. It gives them the ability to adjust it and kind of find a sweet spot that will bring the maximum benefit of simplification, but yet maintaining some of the shape. So the geoprocessing I used in here, it's throughout. It was a very spatial problem, and I also used some things not covered in class, like select by location, spatial join, polygon to line, and extend lines. Batch processing, I've had several for loops in there. I had a for loop with a zip function that looped through those area sizes that the user put in and matched them up with the grid sizes that they put in to create those different size grids, small, medium, and large for the small, medium, and large polygons. I also had a cursor loop that looped through the table and the original vertex counts, compared the original vertex counts versus the new vertex counts, and put those into an HTML table. Code reuse, several functions that I placed in modules, and within the main code, vertex reduction, which I talked about a little bit, create line, which is creating a polygon to line. I had MXD layer which had the function of create layer, which added a layer to the MXD, and several others you see here. Creating postal classes, another one of the requirements. I created a postal code class with the properties of postal code, original vertex count, and new vertex count. I was able to then call a function within that class using the postal code class to calculate the vertex reduction. And you see the table up here is the final result, and I put that into a HTML table for presentation. Script progress, I'm able to inform the user of the progress in the script tool using progressors and also the ArcPy messages, but I also put printed messages in there for standalone runs, so the user is getting updated in both places throughout. My output, I have the final new postal polygons created with the gridded coastlines added to the map in the MXD that you're running your script tool. And I've also exported a map and placed that into an HTML along with the table with the postal code vertex stat counts that were created, and that is opened and presented to the user after it is run. I have some error handling in there, which could be expanded on, and I'd like to test that out more and add more named exceptions to try to catch more errors that could occur. I've also found a bug in my HTML page that if it is in a directory that has a space somewhere, that it will not refer to that image for some reason. So the link breaks and it's not displayed on the page. Another future enhancement I'd like to do is customize the symbology of the output layers and the exported map to give the user a better idea of what they're looking at. So that is my script tool for my GIS540 project, and thank you very much. I hope you enjoyed it.
This is Betsy Boughton. The following will be the demonstration of my groundwater elevation and Vertex concentration, calculation, and modeling tool. The goal of this tool is to automate the process of creating groundwater elevation contours and Vertex contamination plume surfaces from input CSV files. These files contain the field and lab results from annual sampling events from military installations where the groundwater has been contaminated by fuel leaking from underground storage tanks. The image we are currently looking at is an example of the figures output from the script tool, which is automatically added to an HTML web page, which compares the maximum, minimum, and average values of groundwater elevation and Vertex concentration in tables with maps of each input year's data. But these figures and data can also be used in annual reports that my company prepares for the government as part of our contract. The The monitoring well and plume raster symbology is based on standardized symbology used in data reports to the military and EPA. This tool takes 3 or more files as input. By default, the most recent year's worth of data for groundwater elevation and Vertex has already been selected, but I'm going to add in 2 additional years of data. The spatial reference file for the site at which this data was collected has already been added. While the script is running, the progressor label is updated to report which function is currently being executed, as well as messages added as each function is completed and which file was used to complete the function. All of the layers created are automatically added to the map, with the exception of the raster surface used to generate the groundwater contour lines. The symbology and legend are updated, and then layers are toggled on and off based on which year the data was collected in order to export a map for each year of data. The final message added is the full path file name to the location of the HTML file. You can either browse to that folder or just copy and select it where my mouse goes. So this web page has tables of the calculated max, min, and average groundwater elevation, as well as the max, min, and average Vertex value, followed by the years for each year of data. So here's 2012, 2013, and 2014. Last thing on this web page is a link to the USGS website with more information about Vertex.
These excellent projects use 400 and 700 lines of code, respectively. Their code is reusable and portable, so they can share it with colleagues. As the semester progresses, you should be thinking about how you might apply programming in your workplace or research, or to work with some data that interests you outside of work or research. The textbook for the course is available for sale online. Also, an electronic version is available to NC State students for free through the library's website. The PDF formatting is recommended because it's more reliable than the ebook, depending on which browser you use or how large your browser window is sized. The spacing may get changed within the Python code. Data that go with the book, you should download those from the course website. The link to that is also here, instead of using the library's link to the data sets, because these have been updated. Now, be sure to unzip the file so that they appear as they do in this image here. If your data is not in the right place, it needs to be under the C drive. If it's not in the right place, the examples won't work. The concepts presented in this course can help you land a better job, but it takes many hours of practice to plan workflows and implement them efficiently. Learning to program is challenging and it requires a very hands-on approach. This is why lessons are reinforced with in-class exercises and numerous homework assignments. The scripting homeworks will be challenging. The lessons are cumulative and you'll need to apply elements of the first week's lesson to every subsequent lesson, elements of the second week lesson to every subsequent lesson, and so forth. This means putting the new material together with the old material to solve homework problems. Quizzes are useful because they assist with internalizing the material. The grading for this course is based on homework assignments, quizzes, and the final projects. The points that can be earned for late submissions drops exponentially. We use this equation. So, for example, an exercise worth 10 points submitted more than 48 hours past the deadline, but before 72 hours past the deadline, can only earn a maximum of 6 points, and it keeps dropping after that. Expect to work hard and spend a lot of time on this coursework. If you do master these skills, it will pay off. The GIS jobs that require this knowledge pay more than jobs that don't. Grades and comments will be posted in Moodle Gradebook. It's very important to review these comments. If you don't understand a feedback comment, post a message to the instructors on the forum as soon as possible. You have 1 week from when the grades are posted to request any grade changes. Requests are made with a private message post to instructors. We know the material can be challenging, so you should take advantage of the teaching staff help. Use office hour appointments and the message board to interact with the teaching assistants and the instructor when you're struggling with the homework. Beyond this, however, students are required to do homework assignments individually. Study groups may discuss in-class exercise code, textbook examples, and code from course slides, but they may not do the homework together. Copying will not be tolerated. The work you submit must be your own. Examples of cheating are looking at another student's code, writing your program while talking to someone else about it, talking another student through the solution code, allowing other students to look at your solution code, posting your code on the website, obtaining code from a student who is taking GIS540 or took GIS540 during previous semester, obtaining code from family, friends, colleagues, or others. For homework assignments, code snippets from the examples provided for class and the ArcGIS resources help pages are expected to be used. So that's not cheating. However, copying code from other internet sources is also considered cheating. Sharing code on the message board or in other ways is a violation of the NCSU Code of Conduct. If you have any doubts about what's allowed when completing homework assignments, ask the instructors. This kind of rigor maintains the quality of our graduate program and preserves the value of a degree from NC State. Sometimes students get involved in misconduct unintentionally, so to avoid confusion, the policies are laid out in the syllabus. The message board can be reached from the course page. Piazza is an independent platform outside of Moodle, which has some really great organizational and filtering features that are not available in the Moodle forums. When you start a new post, notice that you need to select the post type, question, or note. That way they won't be flagged as something that needs to be answered. You also need to select who can see the messages. So under Post To, select entire class or individual students / instructors. Usually you can post the entire class, but if you're posting questions that contain homework code or solutions, or you're contesting a grade, post to instructors by selecting the second choice and typing instructors in the box. Don't post to Dr. Tadioshan only unless it's some kind of very private medical matter. Post course-related questions to instructors so the teaching assistants are notified of the post. In other words, post to instructors so that more than one person is alerted to the post. When you post a message, you're required to select one or more folders. These are like tags. We sometimes refer to them as tags. It provides a way to select all messages related to a topic. When you're using the message board, you can also filter the messages by unread, updated, and so forth. Additionally, you can use the search box to create custom filters. A filtering by message appears below the search box when you're filtering in some way. To turn off this filtering, use the X that appears to the right of this message. Asking effective questions on the forum takes practice. This is another skill that you can develop in this course. The speed and utility of responses to coding questions depends largely on the quality of the question itself. Be specific and clear. Use copy and paste to include any error messages in the question. Specify the homework exercise name and chapter. Use the code button to preserve the spacing in your code, because spacing in Python matters, and if it's not spaced correctly, it will be very difficult for the readers to decipher. There's a link to Stack Overflow's advice on how to write a good post on this slide. Now, a lot of you may want to help other students, and that's great, but don't tell them the answer. Help them discover their mistake themselves. Otherwise, you're stealing from them. You're stealing the chance for them to have that aha moment, which is when learning actually occurs. Here are the course topics grouped into quarters. Again, the materials are cumulative. For example, to read and write files, you'll need to use the Python data structures from week 1. We are currently using ArcGIS Desktop version 10.7. Versions 10.6 or 10.5 should be fine as well. We'll also get some exposure to ArcGIS Pro. I'll return to that in a moment, but the majority of the work will still be in desktop. Jing is useful for taking screenshots and recording videos to illustrate forum questions. You can also use it to record your final project videos. Be sure, by the way, to find a microphone so that you're not scrambling for that at the end of the semester, because you'll need to have audio on your videos. Homework 1 walks through the installation process for Python Win and PyScripter. Python itself is automatically installed when ArcGIS is installed, so do not install Python again. If your import ArcPy test fails in Python Win or PyScripter, you've probably installed them under another version of Python that your machine has in a location that is not under the current active ArcGIS install. This semester, we will also install ArcGIS Pro and PyCharm. ArcGIS Pro uses Python 3. The installation instructions show how to use PyCharm for ArcGIS Pro's installation of Python. Again, don't install Python 3 separately. This will be automatically installed with ArcGIS Pro. We are installing ArcGIS Pro and PyCharm to provide some basic exposure to this software and so that you can explore changes between Python 2 and Python 3. We will be working primarily back in ArcGIS Desktop and Python 2, and there are some differences with Python 3. So just to be very clear, the Python homework will be graded using Python 2. And this means that you must use Python 2 syntax, otherwise your code may not run when we try to grade it. If your code doesn't run for us in Python 2, this will result in a loss of points. For the program in which you run your code, the IDE, the course examples will use Python Win. If you want to use an IDE other than Python Win as your primary IDE, this is acceptable so long as you have it set up to test your code in Python 2. Be sure to test the code in Python 2 before submitting it, and beware that there may be some quiz questions and assignments that will require some knowledge of how Python Win works. Scripting assignments will be submitted on Moodle. All the deadlines are given in Eastern Standard Time. Yes, we have many students in North Carolina, but we also have students in Hawaii, Alaska, Turkey, Saudi Arabia, and other places around the world. Scripts should be named as specified in the exercise in the book. This is key for our semi-automated grading. Write your Unity ID and name in each script that you submit. We'll talk about how that is done using comments in Python. We will deduct points for omitting your Unity ID and name. Also, don't zip your submission. Another available resource is an online tool called Py4All, which has been developed to accompany the textbook Python for ArcGIS. It applies to exercises in the book in which you write a script. Py4All provides automated feedback and enables you to compare your output to the solution output. It can be used when the script is completed or when you've made as much progress as you can but you're stuck. It does not replace grading, which the instructors will do later. When you're ready to officially submit a script, do that on Moodle. Py4All is more like a sandbox system to provide automated feedback. Instead of a grader, think of Py4All as a helping hand when you're first learning to script. You can use it iteratively by uploading your script, receiving feedback, making modifications, and uploading again to receive additional feedback. The Moodle course page contains links to course resources. I will quickly step through these links now so you will be aware of these resources. Be sure to read any announcements I post in Moodle. Announcements will contain information everybody needs to know, including our feedback to students on assignments and other important reminders. This video discussed rules from the syllabus, but the syllabus contains more detail. Be sure to read the syllabus to clarify the expectations for the course. We already discussed the message board. Moodle has a link to Piazza. Piazza will be our primary platform for interaction with the students who are not in the classroom. We also enjoy meeting with students when possible, so don't hesitate to reach out for help. It can help early in the semester, and this can help to keep you on track. Since it's difficult to find a time that is convenient for everyone, we try to be flexible by making our office hours by appointment. To arrange an appointment, post a message on Piazza and we'll follow up from there. As always, plan for any requested meeting by preparing specific questions for the meeting so that we can help efficiently. Information about remote meeting tools can be found under the instructors link. In-person meetings can also be possible depending on your location and schedule. For remote meetings, we can share desktops using Google Meet or Zoom. There is a GIS540 Zoom meeting set up already so that whenever our meetings occur, we can just follow the link to a live meeting. You'll need a microphone or you can join the audio by telephone. I prefer that you use Piazza message board to contact the instructors instead of email. If you send emails directly to us with course material questions, we will ask you to post the question on Piazza so that we have our interactions all in one place. And in this way, others may be able to learn from your questions too. We already discussed the automatic feedback tool. Moodle has a link to Py4All. There's also a link to the GIS540 zip file. If for some reason you already have a copy of GIS540, please download a fresh one, as I do update this periodically. There is also a link to information about the course project. We'll get back to that in a moment. The gradebook won't have much information at this point as you're just starting the course, but be sure you know how to navigate to this. Along with numeric scores, we will be posting comments as feedback for the scripts you submit. If you can't see a link to the gradebook right now on the left side of your Moodle page, you need to click on the hamburger the 3 horizontal lines, little button. It should be in the upper left corner of the page. This toggles a left panel open and closed, which has a link to the gradebook. Finally, bookmark the middle page, as this will be your primary landing spot for this course. Please pause the video now and verify that you can locate each one of these resources on the course website, and let us know if you're unable to find any of them. Also on the Moodle course page, you'll find the schedule. The schedule blocks specify topics, materials, and activities for each week of the course. Each block is outlined in a gray box. Click on the block titles to see the details. There are 3 main types of blocks in the schedule. These are week, quiz, and homework blocks. A week block contains the topics for that week, and below each topic you'll find the related materials. These materials typically include a chapter from the textbook to read, a video to accompany the reading, the slides that are used in that video, and a link to the in-class exercises that are discussed in the video. Homework assignments generally consist of completing tutorial lessons, responding to short answer questions, and writing several Python scripts. Quiz blocks contain timed quizzes with a short availability window. The strategic approach to this course is to first read the required readings, then watch the video, pause the video when questions are posed or in-class exercises are introduced. Try to solve the in-class exercises on your own, then resume the video to listen to the solution. Solutions to the in-class exercises are either on a slide on its own or in the notes section of the slide. And then you repeat and continue this process. When you read the textbook before watching the video, it's as if you're hearing the materials for a second time. This really helps to reinforce new concepts you're learning. And after cycling through the video, watching, trying the in-class exercises, and checking your work, you may want to then look at the related chapter again before attempting the homework. In fact, trying the code you're looking at in the chapter and testing variations of it can be a really useful technique for learning syntax. I can't emphasize too much how important it is to get into the habit of predicting the output you will get from a line of code. Making a habit of doing this will set you up to excel as a programmer. As mentioned earlier, students complete a project for this course, and there is a link to information about the project on the course page. Instructions for the project, including requirements and evaluations for each stage, are on the linked page. The project can be an opportunity for students to apply what they've learned in the course to a problem that has arisen in their workplace or research. As you saw in the examples near the beginning of this video, the projects often involve filtering raw data, performing geospatial analysis, and visualizing the results. The project is developed in 3 stages through the course. A preliminary proposal is submitted about 2/3 of the way through the semester. Feedback on the proposal is provided, then a revised proposal is collected. This will include updates based on the feedback, additional plans for the project, and a progress report on the current state of the project. Feedback is then given again, and the final project is due during the final exam week. For a brief overview of the project requirements, read the project requirements synopsis, which is near the beginning of the page. That's linked to the Moodle page. And note that the first required submission for the project is a preliminary proposal and this is due in the second half of the semester as specified in the schedule and in a homework assignment. Now we've completed the class introduction and we can get to the fun stuff. Let's return to the schedule and go to the in-class exercise for day 1. In this exercise, we'll use the ArcGIS Python prompt just to get your feet wet. First, you'll need to download and unzip the data, the GIS540 zip file, and place it under the C drive so that you have a G/GIS5/data directory. Confirm that C/GIS5/data/CH01/park.shp exists. You may confirm this in Arc Catalog, but then you have to click on the data directory and refresh it so that the data is not locked by Arc Catalog. Click on the data directory or any other location off of park.shp. If your path looks like C/GIS5/GIS5/data and so forth, you have an extra layer of folders and you need to remove that extra layer. Sometimes this happens depending on your uncompression software, it may unzip it that way. There should be only one GIS5 in your path. So now you're ready to launch ArcMap and open the Python window. Next, follow the instructions shown in the in-class exercise and answer the questions that arise near the end. We'll discuss the answers to these questions in the next video.